maybe one of the directions could be how dark is the face, right? For us, it would be like maxed out.
Very dark.
Yeah, very dark. Like there would be one dimension that would tell the variational autoencoder this is a very dark face, right? This is used actually a lot in like image generation, something called variational autoencoders. What they do is they basically take whatever input you have, they try to squish it down into a tiny little latent space, right? And then decoder that tries to recreate what was originally compressed.
Yeah.
When we have, let's say, a 256 by 256 image, that has 256 times 256 dimensions, right? Because each pixel has a value. Yes. And you can imagine if there's only 3 pixels, you can imagine putting that on an XYZ plane, right? The first pixel is how far it is in the X direction. The second pixel is how far it is in the Y direction, and so on and so forth. Well, now you have 256 times 256 dimensions. Every single image is highly dimensional. But if I were to take a bunch of photos of just a bunch of faces, right? The essence of the face is actually not that highly dimensional. There's always a nose in the middle. There's always a mouth. There's always eyes, right? Maybe one of the directions could be how dark is the face, right? And there'd be one dimension that would tell it how far up in the nose is the nose and how wide is the mouth and things like that. But the fact that there is a mouth is not something that needs to be encoded in the latent space because it's always there, right? Sense. The stuff that's varying is the stuff that's going to be encoded in that compressed middle part, right?